Okay, let's continue on with multiplying radicals. So again, going by what we talked about in the last video, we would have to distribute. Now we can go ahead and multiply these because these all have the same index. So the cube root of 4 times the cube root of 3 would be the cube root of 12. We would just have to multiply the radicands. Minus, then this would be the cube root of 6 times 4, which would be 24. Now our last step is always to simplify if possible. So looking at the 12, there is not a perfect cube in it. And remember, if you need to come out to the side and have your list of perfect cubes, you absolutely can. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27. That's larger than anything we need here. So we can't do anything with the cube root of 12. It has to stay as is. But the cube root of 24, 24 is the same thing as saying 8 times 3. 8 is a perfect cube. We can now take the cube root of 8, that is 2. Whoops. And then we still would have left underneath the radical that 3. So we have to simplify what we can. Even though the first term would not simplify, the second one would. Now we can't combine these because they are different. We have the 12 is the radicand and the 3 is the radicand, so those are not the same. Otherwise we could try and put them together. But we are done with our answer now at this point, once we've simplified everything we can. Let's try a binomial here. And as we multiply, again, we're going to multiply, distributing one term at a time. So 6 times 2 would be 12, and 6 times negative radical 7 would be negative 6 radical 7. Then we would have to distribute the radical 3. So square root of 3 times 2 would be a positive 2 square roots of 3. And a square root of 3 times negative square root of 7 would be negative square root of 21, multiplying the radicands. Now we need to see if there's anything we can do to simplify before we go on. So 12 is a whole number, that's fine. Square root of 7, there's not a perfect square inside of it. There's not a perfect square inside of 3. And there's not a perfect square inside of 21. So actually, this is our final answer. We cannot simplify any further, and we cannot collect any of those terms because they are not alike. Alright, let's do another one. This one here is another binomial. So again, we're going to start off by distributing. So we're going to distribute our square root of 2 first, times square root of 3 would be the square root of 6. And square root of 2 times negative 2 square roots of 2 would be negative 2 square roots of 2 times 2 would be 4. Now we're going to distribute our second term to the binomial. So 3 square roots of 6 times the radical 3 would be plus 3 square roots of 18. 6 times 3 would be 18. And then positive times negative would be negative. Multiplying our last terms here, 3 square roots of 6 times 2 square roots of 2 would be 6 square roots of 12. Now we need to simplify what we can. The square root of 6, well, we can't do anything with that. It's just the square root of 6. I'm going to write it down here so I have some room. Now here, we can take the square root of 4. The square root of 4 is 2. So now we have minus 2 times 2, which is minus 4. We can simplify the square root of 18. That would be the same thing as saying 9 times 2. And taking the square root of each one of those, the square root of 9 is 3. We can't do anything with the square root of 2, but we do have to bring down that 3 again. So that would be plus 9 square roots of 2. And simplifying our radical 12 into square root of 4 times 3, square root of 4 is 2, and when we bring down our 6, that would be minus 12 square roots of 3. Now none of those will combine, so this is our final.